So the aim today is to try to create a sort of see-through wall mechanic. So when we walk up, we can create a see-through. We can make it bigger. We can follow what's going on. We can make it smaller. And when we walk away, it disappears. So let's start making this see-through wall mechanic. So I've just created a simple scene. These are just cubes as walls to create this room, and just populated it with some items from the starter content. This is just a simple character with a nav mesh, and he's been set up to just roam around, which is all rather simple. So in order to create this see-through wall, first we'll need a material for the wall. So from Megascan's Quixel Bridge, I've downloaded this brick wall, which gives us these textures. So what we'll do is we'll just create a new folder, call it see-through, and the first thing we'll need is a material for these walls, and the material is the key to the see-through mechanic. So material, see-through. So that's a normal material there, but the material will need to be translucent or masked. Now if we put it as translucent, and we go to our content drawer, go to our Megascans, surfaces, the brick wall, we've got three textures here. We've got the diffuse, or the base color, the normal, and the ORDP. So if you bring all those in, separate them. The problem with a translucent material is you lose access to the normal. So if we make that a masked material, which should allow us to do the same, we get access to more information, also the roughness. So we can, this is the diffuse texture, we can plug that into the base color. This is the normal, so we can plug that into the normal. Now this with Megascans comes as ORDP. Essentially the O represents ambient occlusion, the R is roughness, and the D or D is for displacement. And each one of those comes through a channel. So the ambient occlusion comes through on R, so we can put that in there. The roughness, which is the OR, comes through the next channel, which is green. And Unreal materials don't by default have displacement, so we can leave the third one off. Obviously, now if we put this material onto all of our walls, so click the first one, last one, details, and we've selected it, so we can just pop it in. So now we've got our basic wall. This is also just a first-person template, so if we just play, okay, so we've got the normal wall. Obviously we can't see through that wall. So back to our material. And in order to see through that wall, we'll need to use some kind of mask. So the easiest way is to use a sphere mask. Basically how this works is the A is the position of the pixel, the B represents the position of the sphere in the world, and this is the radius of that sphere at that position, and this is the hardness of how the edges change. So the A, just to see whether this is working, we can get the absolute, we can just get the world position, just the absolute world position of this pixel, put that in there. We can get the object position in world space. This is the absolute position of that cube or that wall. And if we just give it, say, a radius of 100, now in the sphere mask, the center will have an opacity of 1 and the outside will have an opacity of 0. So if we just see what happens, which is the opposite to what we want, but we'll just to demonstrate that. So if I take the diffuse color, base color, multiply that by the opacity, put that into the base color, and if I put the sphere mask straight into the opacity mask, so we end up with this, which is the opposite to what we want. We just want a small hole. So we go back, and what we do is we do a 1 minus. So we get the inverse. Then we connect both of these here, there. Now we get this hole, this see-through. And we can control the size of it using the radius. So if we make it 25, we just get a tiny small hole that we could look through. Obviously we want to be able to control where this hole is located. So that's how you do it with a sphere mask. What we're going to do is maybe use, the other option is to use a box mask. So type in box, use box mask 3D, and this gives you either a square or a rectangle. Again, it's the same. So A will be the absolute world position, so that's where the pixel is located. B will be the center of the box. We'll use the object position. This will be the bounds. Now the bounds have an X, Y, Z, so default is 100, 100, and this is the edge fall off. Again, we want the inverse. So if we just put this into that, apply and save, and now we should get a square. Go back to the material, and rather than using the sphere, we'll actually just use the box mask. So we can get rid of that. We can save this value, so type for named, reroute. This is our mask opacity. So that saves us from having to get spaghetti lines. What we need to do, though, is to find some way, and if we go back here, we can now just do mask opacity. Put that into that. We can copy and paste this, duplicate it, and put that into the opacity mask. But how do we change this position? Now, in order to send information into this material, we'll probably need to create a material parameter collection. So go back to your content browser, right-click, go to Material, and choose Material Parameter Collection. This will be our MPC see-through. We open that. So this allows you to set scalar parameters and vector parameters. We could set the bounds as a vector, but just to make life easier, we'll assume that the bounds are the same in all three directions, i.e. a cube. So we can set this just as a scalar value. Do that. So press 1, the default value will be 0, and the name will be bounds. Back in the material, we can get access to this value by right-clicking, typing in collection. Will give you the collection parameter. We've only got one material parameter collection, so that's automatically entered for us, or we can just click. And the parameter name that we want is the bounds, which we set here. Now we can put that straight in. That gives us the bounds. The other thing we want, though, is the actual position of where the window to see through will be located. So that will be as a vector. Click on that, add one. We'll call this location. And we'll save it. Back to our material. So instead of using the absolute position, again, we'll get our collection parameter. This time we'll choose location. And we'll put that in there. So we need to find a way of sending data into that, setting these values on the collection so that they come through and are piped into the location and the bounds of where we want our see-through window to be located. So we'll do that using a line trace, and we'll run that line trace through our player character. So we're using the first-person player template. So I'll open up the first-person player character. I mean, not the controller, sorry. I'll go to the first-person blueprints and where's the character? Here. And open the character. So nothing has been changed on here yet. So the first thing we'll need to do is run a line trace. So we'll do a custom event. We'll say trace for a see-through wall. And we'll do a line trace by channel. Now we could use one of the channels that already exist, but seeing that we only want to be able to see through certain objects and not all objects, what might be easier is if we create a trace channel, custom trace channel, and a custom preset for the walls. So we go to our settings, go to our project settings, come down to collision. Here it will say trace channel, so we can say a new trace channel, and we can call this the see-through trace channel, and the default response will be to ignore. Here you can create presets that you can add directly to the actor. So let's just create one for our see-through walls. So we'll call this a see-through wall. We'll want this to be collision enabled, a wall static object, and this is see-through walls with see-through material. And on this, instead of ignoring it, because we want to trace for this channel, we'll put this as block. And we'll accept. Now we can close this, try to save everything. And if we go to our cubes, which are the walls, select them all, and find collision. So the collision preset is normally block all. We'll change that to see-through wall, which we just created. And if we open that, we see that it blocks this see-through trace channel. Now if we go back to our character where we're doing the trace, just save it. When we click on the trace channel, let's just get rid of that. Do the line trace again. Line trace by channel. We should now be able to select the see-through channel to run our line traces. And we want to run the line trace from our camera for a distance ahead. So we can just say get player camera manager, which is an actor. We can get the location. Which will be the start of our line trace. We can find out what the forward vector is, so which direction we are tracing. Get actor forward vector. Just multiply this. So how far ahead do we want to trace? We'll put this as a float. Say we want to be able to trace from a distance of 5 meters. We can always tweak this, so that's 500. Then we add that to the original start location. And that becomes our end. We should be ignoring our self. So if we just do a debug for one frame, we can see whether we're hitting the wall. So first we have to call. We'll probably need to run this trace on the tick function. So type in tick, and we will say trace for see-through wall. So as we hit the wall, we get that red sort of square that tells us that we're hitting the wall and not hitting anything else. So once we hit the wall, now we want to be able to set the data on that material parameter collection that we created, which will feed through to the material. So if we do get a hit, we can branch on this. We can break the hit. So we do get a hit. This is the impact point of that hit. We want to set this as the location where our see-through window appears. So how do we set a value on a material parameter collection? If you just right-click and say Set, we want to set a vector location, isn't it, for the location? So Set Vector Parameter Value. Under Material, this one comes up, says Target is Kismet Material Library. Now here we can just click and we can choose our material parameter collection. And here we automatically get, we've only got one vector, so we get this. And we want to put the impact point. Now this is a linear color, a vector 4. This is a vector 3. But Unreal will automatically convert that for you. Just plug it in. The other thing we want to change is the bounds. So again, just say set scalar parameter. Under material, set scalar target Kismet material. Same again, choose the see-through material. We've only got one scalar value, choose that. And maybe we'll just give it a 50 to begin with. When we are no longer hitting the wall, we want to get rid of the see-through. So basically we are doing the same thing here again. So copy and paste. We'll just set this, we'll split it and just set it to 0, 0, 0. And we'll set the parameter, so the bounds, to 0. File, and let's see if that, so there we go. So now we've got a see-through, and we walk away, it disappears. We can see what's going on through the wall inside the room. So that's the basics of how that works. So how do we make that window bigger or smaller? So we can see more or less inside. Let's just have a look first. So what we want to change is the value of the bounds by being able to change this value rather than it being a fixed value. The other thing, it's worth probably just checking complex here, just so that the trace is a bit more accurate. Okay, so we need to add some new input actions. So right click, go to input action. So input action, see-through window. Double click and open it. So by default it's a bool, 0 or 1. But we want to be able to make it bigger and make it smaller by using two different keys. So we'll change the value from a bool to a float, axis1d float, because we just want to know whether it's positive or negative to make bigger or smaller. Then we will save it. If we go to our first person input, so this is our default mapping context used by the game. And if we just open this, these are the keys we're using: jump, move, look. We want to add our new one that we created, which was IA see-through window. And I'm going to have two keys, so I'm going to use so click on that in the right bracket to make it bigger. Click on that, the left bracket, to make it smaller. Now in the triggers and the modifiers, so I click on trigger, we can choose what triggers it. What I want to do is that when I hold down the right key, the brackets, it keeps on triggering to make it bigger and bigger and bigger, or smaller and smaller and smaller. And the key, what I found is that perhaps use pulse, so a trigger that fires at an interval while it's being actuated. So while you're holding it down, it will keep firing. So if I do pulse, I open that, so it will trigger when I hold it down. Here is the interval in seconds. So the default is 1, but I wanted to trigger on tick, so I put that to 0, and I don't want there to be any trigger limit. And the same here on the left bracket. We'll choose pulse, open it. We want it to trigger on tick, so we'll put that to 0. The difference here is that we want the left bracket to give us a negative value. So if I click on the modifier and I choose negate, this will now send through the negative value. This will send through a positive value. So click on that, go back to our first person character, and if you right click and do IA see-through enhanced action event, we should now be able to access every time it's pressed. So every time it's triggered, I want to do something. But I only want to do that if we are hitting a see-through wall. So perhaps we create a variable saying see-through wall trace active. And here, when we do hit, we'll set that to be true. And if we're not hitting, we'll set that to be false. So before we make any changes, we check to see whether we are tracing a see-through wall. So we can branch on that. And if we are, what we're interested in is this action value. So if I press the right bracket, it should be positive, and the left bracket, it should be negative because we added a negate modifier. And we want to change this value here, the bounds. So we create this as a variable, call that our see-through bounds. So see-through bounds. We'll get our see-through bounds, and we will say add So we'll add the value. It'll either be positive or negative. Then we'll do the same. We'll say set scalar parameter value on the collection. Choose the collection, see through the bounds. We'll set this as the new value. So we'll say set so that should make the window bigger or smaller while we are tracing. Here we go and have a look. If I press the right bracket, it gets bigger. Press the left bracket, it gets smaller. I can set limits on how big or small it gets, but otherwise I can essentially make the whole wall disappear, and then it will reappear. We probably want the bounds to reset when we are no longer tracing. So when you come to an end here, we can change the bounds value. So we can set that, and we probably want that to go back to 0. And then we can just use the variable value here. So I make it bigger, make it smaller, make it bigger, come along, disappears, I go back, it goes back to 0, and then I can make it bigger again, or make it smaller. And as the entire building has the same material, we can see through wherever we go. As you can see, there's not much of a boundary. So if we wanted to put a sort of a rim around the edge, we would probably need to do that in the material. So if we go back to our material see-through, we can probably take advantage of this fall off. So let's just make that as a parameter. So the default fall off is 1. Let's just put that as 1. We probably want to, in essence, a fall off is how things change at the edges, or how it goes from a opacity of 1 down to 0. So if we go and maybe get a texture, so hold down T, left click, find something with a grid. Let's try this. And what we want is that, depending on what the value of the opacity is, we'll decide which texture to put through. So to decide which texture to put through, we'll use an if node. And the number we'll compare is the mask opacity. So right click, mask opacity, named reroute. We'll compare it to the number 1. And we'll say if the opacity is 1 or greater, we'll put through the brick material. If it's less than 1, so That's where the see-through material, the see-through effect is coming through. We'll use this grid material and we'll plug that into the base color. And just to make it more obvious, maybe we'll change the fall off to 5, so that will make it slightly thicker. And if we apply that, save it, and have a look, and make it bigger. So we now get this kind of a sort of framing. And it disappears. And we can tweak how big that boundary is. The other thing is we can maybe add some effect to it. So if we do a panner, and we just make it pan slowly. And play. So we can get this slight effect around it if we want to. Make it smaller, disappears, and bigger. So when we start off, we're getting this round circle there, which maybe we don't want. The reason for that is actually is our default value. For the see-through bounds, we've set at 50. Put that down to 0. So we could make that less obvious just by making this a smaller number. But then again, it might give us some visual feedback that they're on a see-through wall. Goes. And we got a little framing effect around it. And we can get rid of the line trace debug. So when we walk away, it kind of disappears, it snaps away. We want to animate that into a big window becoming smaller. We could do that in the character as well. What we would need to animate is the bounds from its current value back down to 0. So we would probably need to do that on tick. And we would only do that if the see-through wall was not active. So we could branch on here. On see-through trace wall. So if it's not active, we want to set the see-through bounds from its current value to a new value, and we can do that using an finterp. That's its current value. We want it to go down to 0. The delta time, we can say get world delta seconds, And the interp speed, we can put, say, 5. Then we set that, and we do this on false. That means we don't need to do this anymore, so we can delete that. Come, make it bigger, walk away. The reason why this isn't working is because even though we're setting it slowly down to a smaller value, we're actually changing the location back to 0, 0. So the box has disappeared from where it is to a location that is not on the actual brick wall. So we need to save that location. This impact point, we need to save it. This will be our impact location. And we can send that through to the parameter first time. Here, instead of setting it to 0, we can recombine this, and we can again set it back to the impact location. But we can change the impact location depending on the value of the bounds. So we can say we've made the pound smaller, so it shrinks. We can get the impact location, we can set it, and we can select what to set it to. So if the bounds are less than, we'll choose a smallish number, say 0.1. If it's less than 0.1, set it to 0, 0. If it isn't, leave the window in the same location. Let's see if that works. So we come across, make it bigger, walk away, and it shrinks. Make it bigger, have a look around, walk away, and it shrinks away. We go up, it shrinks again. We could add a widget to make it clear to the player when they are able to activate the see-through mechanic. So let's try that. Go back to our see-through. So we could add a widget to make it clear to the player when they can activate this see-through mechanic. Let's try that. So see-through. So let's add it here. So user interface, widget, user widget. Just add a canvas panel. Border. Text block to the border. Size the border to content. Change the color of the text. we'll position this. So Command Shift click, -100, and we'll just say press X to see through. Compile, save. So that's very simple. Go back to our first person character. First we'll probably create this. So begin play. We'll create the widget. WBP see-through. We'll promote that to a variable. We'll hide it to begin with, so set visibility to hidden. And then we'll just add it to the viewport. So when do we show the widget? Well, we show the widget when we have a trace, isn't it? So here we will say at the widget set visibility to visible. And when we are no longer tracing, we'll hide it. So we come, press X to see, go away, it disappears. But now let's create the input action. So input action, IA trigger see-through. Then go back to our input mapping context where we added everything else. It's this one, not that. So the IA see-through window, we'll add another mapping context. This one will be our IA trigger see-through. And we said that would be X, so just click on there, then press X. And we don't need to change anything here because it's just a bool value by default. Go back to our character and we can access see-through window. So here we'll just do it when it started. What we want to do is probably have a bool to tell them that, tell us when it's been triggered. So we can do another bool, say player triggered see-through. But they can only trigger a see-through if the trace is active. So we get that branch on started. If that's true, we set that to true. On the other hand, they can only trigger this see-through window bigger or smaller if they've triggered the see-through. So both of these need to be true here. So we can do an AND Boolean. Put that there. So they trigger the see-through only if this trace is active, and then they can only make it bigger if they've triggered the see-through and the trace is active. We then need to show and hide this differently, isn't it? So if they've triggered the see-through, we can say get. We can change the visibility depending on whether they've triggered it or not when the trace is active. So again, we can select based on this. If they've triggered it, then we can hide it. If they haven't, then it will be visible. And here it will go back to invisible. So I start, that shouldn't happen, should it? The mistake we made here is we've got the same one twice. So get rid of that. We want IA trigger see-through. And that goes on started. So now if I go here, it says press X. If I press the right bracket, nothing happens. If I press X, the widget goes. And now I can make it bigger or smaller. When I move away, it shrinks. I can't make it bigger or smaller. And when I come back, so it should be showing the widget again, but it's not. The reason for that is that at the end, we have to reset player triggered see-through back to false. So we play, press X, press X. Now I can make it bigger or smaller. I go away, it shrinks, I come back, it says press X again. I can't make it bigger or smaller when I'm pressing until I press X. And now I can get my see-through window. And I can watch what's going on inside. Press X. And there you go.